Hello and welcome. In this video, we are going to apply the voltage divider equation to find the voltage between nodes. So we were given this circuit here. It has a 17 volt source. It leads up to a R1 resistor at 17K or 17,000. It goes straight down through past node A right here to a 16,000 ohm resistor, and then it continues on to a 10 kilo ohm resistor here where it sees node B, and then it retreats back to our negative terminal. And so we know this is a series circuit. Even though we have these node A and node B lines on here, they're not going to change the resistance in the circuit. They don't make it to ground, right? If they were connected across the back, then they would make it to ground, and that would be a different story here. But since we're just having those probe lines out there, they're not going to change anything for our connection. And so we can apply our voltage divider rule. We're going to say what we want to know is the voltage between these two nodes here. We can call that VAB. Right, that's our voltage drop between nodes A and B, and that's what we want. So VAB is what we want, and now we want to put what we want on top, and that's anything between nodes A and B. Right, and we said that was R2 and R3, so we'll put those in series on top by adding them together. R2 plus R3. On bottom, we want to have our total resistance, RT, and we see that that was a R1 also, so we're going to put R1 in series with R2 in series with R3 all on the bottom there. And I like to wrap these ones up in parentheses to make sure that those sums actually add before we multiply. After that, we just want to apply our voltage source, and that is our 17 volts. So that's our VS here. So we can plug this into our Desmos directly. So we'll open a parenthesis for the top, and we'll add our two resistors on top, our 16 kilo ohms and our 10 kilo ohms. They're all going to be in kilo ohms, so we can just leave that kilo ohms off, and the ratio is going to work out for us on this one. So we'll say 16 plus 10. That is our A to B resistance, and we will divide that by 17, that's our R1, plus our 16, that's our R2, and plus our 10, that's our R3 on bottom. Right? That gives us a ratio, and immediately we see 60%. Right? If we were to multiply that by 100, we would get 60% of the total voltage is going to drop between the nodes A and B. So now we're going to multiply by our voltage source of 17 volts, and we're going to get the actual voltage that that represents out of that 17. So VAB is equal to 10.27. We can round that up to 10.3 volts. Right? So that is the voltage that we expect when we measure across here. 10.3 volts should be seen on a multimeter if we were to do that. All right, let us know if you have any questions.